Hi everyone, I am Hüseyin Türker. Today I will present you our data intensive application project. We did this project together with my teammates Arif and Esaydın. The name of our project is Predicting Diabetes Using Survey Data. Problem of our project is diabetes, of course. Diabetes is a global health problem affecting of millions of people. Early diagnosis and treatment are very important in this problem. In our project, we focus on identify individuals at risk of diabetes using basic patient data collected from survey. By analyzing this survey data and using these deep learning models, we aim to improve early diagnosis and solve this problem. In related work, when we start the project, we examined the studies in the literature. You can see two of them. First one is an investigation of machine learning algorithms and data augmentation techniques for diabetes diagnosis using class imbalance BR-FSS dataset, and use this feature BMI age and models and get these results. Use the 2021 BR-FSS data. In study 2, building risk predictions model for type 2 diabetes using machine learning techniques. In this study, use these features, BMI age group, and these models, and get these results, and use the 2014 BRFSS data. In our project, we use the BRFSS data. This is the BRFSS data homepage. You can see the description of BRFSS data and different years data. You can see the 2015 to 2022. In our project, we use the 2018 to 2022 survey data. We combine this 5 years data and use our project. What is the BRFSS data? The Behavioral Risk Factor Survival System, also called BRFSS. This is the largest continuously conducted health survey system in the world. This data includes health behaviors, alcohol, diets, and physical activity, chronic health conditions, diabetes, heart disease, and obesity, preventive service, checkup, screenings also include. Demographics, age, gender, ethnicity, income, education level, and also include other variables. For example, mental health status, healthcare coverage. The BRFSS dataset is invaluable for public health research due to its comprehensive scope and detailed health-related information. This is the description of BRFSS data. In this part, you can see our data pipeline. We get the 5 years data 2018 to 2022, and we combine this data, 5 years data, we get interim data, and apply some data preprocessing technique, for example, data cleaning, feature engineering, missing data. The dataset includes loss of missing data and missing values. We get the proceed data. You can see our dataset statistics. Each year, for example, 2018, our data includes 275 column and 437,436 row. You can see our other years data statistics. This is the raw data. When we combine this, we get this data, and we use this data in our project. For example, literature review data. When we look at the literature studies, we get some features and we create this data. And also, when adding this literature review, we can apply some statistic analysis. For example, Kikare and correlation. We get the analysis result data. In literature data, our data include 66 column. In analysis data, our data includes 94 column data, and we use this data in our project.
After the data part is complete, we focused on the imbalance problem of the data since it is moderately imbalanced. 85% of the data is not diabetes and 15% of the data is diabetes. We had to address this problem because in the end it affects model performance. It makes the model biased. We choose to address it before training using sampling methods. Before testing sampling methods, we split the data set into train and test sets since applying it on both leads to data leakage. So we applied imbalance techniques on training sets only. To test different imbalance techniques, we used imbalanced learn framework. These methods are based on sampling and uses nearest neighbors to check and operate accordingly. From the table, we can see that undersampling methods slightly performs better than the other types, but undersampling methods not guarantees the balanced data. It stops after some iteration, and oversampling methods slightly worse, as well as they are slow and memory heavy. Especially smooth variants are slower than adaptive synthetic, so we focused on that. And combination methods are applies these undersampling and oversampling methods back to back, but generally they are too slow, memory heavy, and not flexible, not allows other variants. So as a result, we first applied edited nearest neighbors and then applied adaptive synthetic method to obtain balanced data without losing too much performance. You can see the resulting dataset distributions on below.
Modeling. In our project, we use XGBoost and random forest deep learning model for classification. You can see the pipeline. After process data, we split our data train and test. In train data, we also apply some balancing technique, and we get the balanced rate data. Also, we use the imbalanced data, and we get the balanced and imbalanced results for XGBoost and random forest model. Uh, in our project, we use XGBoost and random forest because these ensemble learning techniques effectively capture complex patterns and relationships within the data. When we look at some literature studies, most of studies use these techniques, so we choose these models. In evaluation, you can see the XGBoost results. We have four types of data: imbalance literature review, imbalance analysis, balance and balance analysis, balance literature and balance analysis data. You can see the results. When we look at the balance and imbalance, recall and F1 score increase generally both of XGBoost and random forest. You can also see the imbalance results and balance results. For example, our recall value in random forest 15 and balance recall value is 660 approximately. You can see our results. We get 84.96 highest accuracy score in imbalance analysis result data. We get the low recall and F1 score in imbalance data because our data class distribution is 85 to 15. This is the reason, I think. You can see our references, and thanks for listening.